So welcome to my session, almost slideless. My name is Adam, been working with Java since 1995. Before that, C and C++. And I used virtualization, then VirtualBox, and then played with Open Solaris and containers or zones. This was like the container technology on Open Solaris. And then Oracle bought Sun, and there was no Open Solaris anymore, or at least no more accessible for me. So, and Docker came out, so I switched to Docker and run my server on Dockers. And 1 year later, Docker exploded a bit. And this is my history with Java, and not exploded, become very, very popular. That's what I meant. And yeah, and this is the history. What I'm doing, I'm working with Java EE mainly as a consultant, and write a blog, which is more or less a notepad. And this is partially interesting. So if you have questions, gather the questions, and answer all the questions once a month at 6 p.m. Monday, the first Monday of the month. There are people from all over the world. It's actually funny. And some workshops, there are lots of people from Sweden, and you can ask me questions at any time, in English if possible, because I only know Kalle Anka. This is what I learned, and TAG, of course. So this is the last slide. So how a microservice starts. This is I would just create it from scratch, and I will call it macro. Why not? And what happened is I used a wizard called archetype. This is Maven. For the JavaScript developers, is something like Webpack, very similar. But a bit older. And what it does is it basically says there's only one dependency. This dependency will be never deployed to the service. So what it means, the service will comprise just business code, and we will use Java 8, and the name is going to be macro. So I could build that with my IDE, what I usually do. This time, we have no time, just 40 minutes. So I would like to deploy it to Docker straight away, right away. I think microservices without Docker is a little bit problematic. So at least I think the container technology is the future. So Docker or Rocket or whatever will win, I think. So I would like to show you how it works. So what happens behind the scenes? I have a JAX-RS endpoint, which is going to be a like HTTP API endpoint, which always happens in all my projects. So we have a kind of REST HTTP JSON endpoint for React, Angular, or whatever. And this is configured, so all you have to do for the configuration, so what means it becomes accessible under the name resources. And this basically is. So just create a service, and I will call it macro resource. And call that macro, of course. Oh. So, and then say hello, and get request, and say good morning, Øredev. I don't have these special characters here, or at least I don't know how to print them. So this basically is. So what I did, I built an service with a string. We can do later with JSON, but it should be enough. So I will switch here. So Maven is like Webpack. Very easy to use. Maven clean install is all you need in microservice world. Even package would be enough. So it built everything in 1.2 seconds. So no one is interested in this because what we just did, I created just a var, which is tiny, 3K, but there is it's not executable. So it's not a microservice. So for microservice, I would expect to have something executable. And this is where Maven kicks in. So let's do it with Docker. So I would like to create a Docker file, and this is going to be Docker file. In the root of the project, usually you can place it whenever you like, but this is, I think, convenient to place it here. And in Docker, I have to say from which image is going to be taken, and I would just say I would like to use airhex Payara. It's like application server. Later we can switch to Whitefly, whatever. It's just a matter of a string. And then I would like to copy something which resides in target macro.var. This is here. Why this? This is this macro.war, and then put it to deployment dir. Deployment dir. I'll show you where this comes from. But what I'm more interested in, the speed. So check this out. So what I would like to do, I would build right now a fully executable image, which full-blown application server. They are suspected to be large with JDK 1.8 and CentOS 7. So Maven clean install again. So do it from scratch and build. -t, I call it Øredev macro. I have to remember the name and not build Docker build. This is my common mistake. Docker build. And the first command builds the war from scratch, no more necessary. And from here, we build a fully executable image. So now we could run the service. Before we run the service, I would like to look at the images. I have a couple of them. But the last one has to have something to do with Øredev macro. And you can see it is macro because the size is 700 megs. I say, okay, you are crazy. You cannot build a Hello World app, which is the size with 700 megabytes. And this is common misunderstanding how microservices and Java EE and Docker operate. What does it mean is the full service. So what we can do, we can look inside this. And by the way, as you probably know, all Macs are outdated. So they were not updated for years. So I would be never able to build 700 megs in 100 milliseconds. Agree? This is technically impossible. Okay, Docker history, what was it? Øredev macro, I think. So, and as you can see, this is what happened within the image. So you can see 9 weeks ago, I installed the base image, which is basically CentOS 7. So this is the base layer. And then the application server came here with 140 megs. There were probably some tools. No, this was JDK 1.8. There were the tools. And what I did today, 59 seconds ago, is 3K. And this is why this thing is crazy fast. So why so fast? Because the wars are tiny. Why the wars are tiny? Because we have application servers, and they are built only once per machine. And so I can launch it, of course. Docker run RUP would be nice. -d, -p, and I hope this port is not occupied. So what I'm doing, I'm exposing the port 8080 of the application server to 8080 outside. I call that macro 1, and Øredev macro is the name of the image. So it started, and we can look inside the image, and it was deployed somewhere here. There was, yeah, macro. So now the service should be available. So let's, this is the last slide. It was, I think, just go. So this is the Payara. What was it? Macro, resources, and I guess macro again, right? Yes, good morning, Øredev. So this was the worst possible case without any automation. I created from scratch a service, run it on CentOS 7, JDK 1.8, and built everything from scratch. And this is what happens in my projects several hundred times a day. So at each commit, the whole pipeline is built. The interesting part is, the larger the war, the slower the build, of course. And this is why we never use any micro technologies where the application servers are packaged together with the war, because the slower the build, the more or the less productive we are. And this is actually the smaller the war, the better it gets. Questions so far? You can ask questions. No questions? Everyone happy? Perfect. So we have this. Now the question is what we could do if we would run it, for instance, on Whitefly. Then I will switch to Whitefly, and then in a second I will show you what this actually means here. So now it should run on Whitefly. And I only have to build this. So it's built again. And now run it on different port. I will call it macro 2. And A2 looks nice. Docker logs macro 2. And this is Whitefly. So our system was deployed on Whitefly. Important note, I get lots of questions whether I'm using, Whitefly web profile or small profiles or whatever. And my answer is I always use the full profile because it does not matter. So this whole build takes 100 milliseconds. If I would use micro, it will take 80 milliseconds. No one cares. Okay? If you have the full profile, have the full possibilities. Still no questions? So we have two services. One running on Payara, the other one on what? Whitefly. So curl, do it again, and now I will just use here H2 that you actually see it's served from Whitefly. Undertow, yes, is Whitefly. Okay, now is the question, what is this? So, and this is actually the structure, how we structure the Docker images in production. So this is an open source project called Doclens. So I exposed all the images, and I would like to show you how I structure such images. So this is the first image. This was what was built 8 weeks ago, and this just contains CentOS 7 and Java. One of the most asked questions is why I'm not using Alpine Linux, and the answer is because it does not matter. It only sits once per machine. So this image would be, I don't know, 100 megs or 50 megs smaller, but it usually does not matter on servers. It builds Java. From this image, Whitefly image inherits. So we have here a Whitefly image. It inherits from this image. And the interesting part for operations is the first image is only built in case we get some operating system patches. Like, for instance, CentOS or Java 8. The next image, the Whitefly image, is only built in case the application server get patched or new version is available, what usually happens every 3 months. We get a new release of Payara or Whitefly. And now the cool part, this what actually changes was my last image, which I created right now, and this changes frequently, but this image was 3 kilobytes. So what actually happened was, per accident, or accidentally, Java EE became actually the best platform for microservices, because what we are building is tiny, and the platform rarely changes. It only changes every 3 months. What happened is in this year, I got lots of such projects, so all my project looks like that, and no one could believe that it actually feels like that. And we can move freely between application servers. No one cares anymore about the application servers, because from the outside, we just see the JAX-RS endpoint. And the main motivation is productivity, not because, and of course, monitoring and all the features we get then for free. Why productivity? Because we have this, and we don't have to think about whether we use Jersey 2 or 3 or CXF or whatever. Everything what you need is there. And this is the initial work has to be done. And most of the larger companies are pretty happy because there is no change to existing projects. So not like we need, Docker plugins, whatever, Maven plugins, there's actually no change to existing applications. Still no questions? Great audience, so Sweden is perfect. So what you can do right now, I would say then implement another service, or first, one of the asked questions, okay, how you can actually configure services. So let's say I would like to have here a configurable message, string message, and this message is injectable here and has to be configured and from externally. So a big deal is configuration. So the cool story is we have dependency injection in Java EE, and this could be stateless, singleton, application scope, it doesn't matter what. And what I will do, I will create a small configurator. And this configurator will expose the configuration. Configure injection point IP produces configuration. Why I'm doing this? Because there are lots of attempts, to introduce third-party frameworks, whatever, and I think it's not necessary because what I'm trying to show you how easy it actually is. What I get here is the name of the field name, and in Docker, what we do, just in Docker, return system get env field name, exactly, this was right. This is better. And now get our default field name, and let's say not configure is the default. So, and this is just for now because we only have 40 minutes. What usually would happen, we could access a custom annotation here and specify the default annotation and specify any hierarchical structure you would like to see. So, and now we are ready to go. So this should be injectable here. Inject. So, and now let's build this again. This was full build. And run, and usually I use IDE. This is the, I would like to show you the worst possible case. I only have VI or whatever. So let's say 8484. And the name has to be unique. So I will name it 3. And now what you can do, I could specify here -e and key values. And let's say the message is Anka. I forgot. So now it started, curl 8383. Oh, thank you. Great audience again. Good morning, Øredev Anka. So of course I could, include 50 different libraries, but there were 2 lines of code. With additional annotations, we can, solve 80% of usual configuration problems. If you are curious what I did on my GitHub, I did the same with Jcache. So if you put the configuration in Hazelcast, you can replace everything in real time, but usually it's not needed. So what we gain with that, we can keep the same binary and move from stage to stage, from dev to integration to prod without changing anything. And of course, you can specify the properties with -e, or you can specify a file with properties, which is actually business as usual in operations. Questions? Another nice hack is if something does not run in a container, like for instance external resource, and you would like to configure the URI, what you can do, you can specify add host with Docker, which will resolve this in etc hosts. Okay, microservices have to communicate. The question is how to implement this, because without containers, without virtual machines, I would just use localhost and it would somehow work. So in Docker, virtual machine or whatever, there is no localhost. So I will talk to myself. And to illustrate you this, I will create a Docker network. So Docker network create Øredev. Docker network ls, and Øredev is created. Docker network ps, and just Docker ps. And what we see here, we have here macro 1, or just take the macro 3. What I could do, I can say Docker network macro 3, Docker network Øredev, connect Øredev to macro 3. So Docker inspect, Docker network inspect Øredev. What we should see, now we have a network defined which is local, and the macro 3 is within the network. And what's cool about that, the container name becomes the host name. So if 2 microservices communicate with each other, you don't usually need a registry. What you can do, you can just rely on the names, and then Docker will resolve the IP address for you. So this is built-in technology. This is just Docker without any additional tools. So what it basically means, what I could do, let's try this. I will run a plain container. Docker run airhex java ping macro 3, right? Yeah. So is this timeout? So nothing happens. Docker run airhex java, and I will launch it in the network Øredev. And you can see I can ping that. So what I did, I just interactively running this ping macro 3 in the Java container, and I can immediately access this macro 3. So if I would more time, I will create another war, which uses in place, which communicates in place with the other one, just using the logical name macro 3. And this is great because we get rolling updates and no fixes. The only thing I have to do is I can change here, it's still locked. I could say Docker network, Øredev, this, always wrong, disconnect Øredev. This is a little bit strange, but usually I write scripts for that. Disconnect Øredev, what was it, macro 3. So it's disconnected, and this guy is no more visible. So what we could do, we could introduce in running system new containers, and they become visible, or swap them. This is actually, together with HA proxy, more than enough for rolling updates. So this is what we do in smaller projects always. I'm not at Facebook or Twitter. This would be not the right technique. But in larger systems, what we usually do, we either use Docker Swarm, for instance, or OpenShift with nicer UI. What I show you here is just basic. What you can achieve without any additional tools with plain Docker and plain Java. Still no questions? Everyone agreed? Yeah? No. Perfect audience. So, okay. We configure this. This worked surprisingly well. So we have 15 minutes. And ask me questions now, because I really have to go at 11 because of the train. So let's create another service. The question is how they communicate. And I call it now micro, just for fun. And micro will access the macro 1. So, and the microservice will have also a path, and I call that micro resource. And call that micro. And now I could just say hello get. And here, what I would like to do, I will access the other service, just to show you how it would work from code perspective. And for this purpose, what usually happens, I have a post construct method, it's like a hook. And here, I can say client, builder, new client. You don't still no additional libraries, part of the platform. Target, and the target is going to be this. Almost this. The cool story is, we don't care about the port. The port don't even has to be exposed. This is the default port of the application server inside, regardless how I map the port. If I would start the microservice without the port mapping, it wouldn't be available from the outside, only available within the network. And macro is completely wrong. I can now choose, macro 3 or whatever, and I could inject that with my add inject thingy, which I built before. Okay, so then it will be fully configurable system. So you can ask, okay, what if you have 50 microservices? I say, okay, then we need probably something else, but usually we don't have that many. So what usually happens is a small team creates a war, and even a larger projects comprise 5 to 10 microservices. I never had the case, I only heard about that there are projects with 50, hundreds of microservices. This is what usually not happens in my area right now. Who knows what happens next year. What this was, just perfect. So just, let's say, okay, we can do it in 2 steps. So I'll just say this is the client, and too much. This would be the URI, which is could be hard-coded because we have the network right now, and this is not exactly right. And what we could do, first we have to save the target, and I call it macro target. Remember the field. And then I could say this macro target request and get the other side. And what I get back is the response, and what I could also say, okay, this is too fine-grained, give me the string or JSON or whatever, or usually JSON. So it would look like this. The problem I have from microservices perspective, I need the bulkhead pattern for the problem which I don't have yet. The problem is this could kill the whole application. What happens if this becomes too slow? Then we'll slow down this service, and then all threads get occupied, and everything dies. This is actually a common case. Lots of my projects are resolve exactly the problem. And the solution to the problem is bulkhead. Good news, it was part of application servers forever, but forgotten feature. So how to use that? First, we have Java 8. So what we could do we could make it a little bit nicer. So what I would like just do, I would create another method and call it get remote message, for instance. Make it a little bit nicer. So here. And the cool story is, I could just rewrite it a little bit and say, this is asynchronous. So, and this response has a method resume, and this resume can get this. So what you can do, you can build pipelines with that. So this is crazy, would work, would be no difference, but this is what happens behind the scenes. So what we can do, we can simplify this a bit, and we could say, completable future. I guess you know Java, so we can skip all the introduction. Supply async, this, get remote message, then accept response resume, and we have nice, I would call almost reactive pipeline. Part of Java 8. So what happens? Now, this is asynchronous, so the HTTP thread is no more blocked. This message is fetched in a thread, which is actually wrong for now, but we will fix it in a second. If it's done, it is passed to the asynchronous thing. The thread wakes up, and the answer is pushed to the client. The problem is, we saw it already, is this. It's based on fork join pool, so this fork join pool starts twice the amount of threads what we have cores, so which is not predictable. So how to fix that? Thankfully, we could do something like this. Executor service. Executors. New fixed thread pool, for instance, or this is too much cached, has no parameters. And then remember this. This pool, and I can pass the pool here. Now, this thing gets executed in the executor service pool. The problem is, of course, is my pool is not managed by application server. No one monitors the pool, so it's not a that good idea. So thankfully, we have the simple technology called Java E. What we can do, we can say this is a managed executor service. And we can inject this. And now it works as before. And we use the managed threads from application server. And what we can do, we can introduce on the fly new managed executor service, because there's also a managed thread factory. So you can even create your own pools on the fly. And this this is the bulkhead pattern per definition. And in task forces, we remove, for instance, Hystrix from Java E, because this is exactly what Hystrix does behind the scenes, with a nicer programming model. So there is no need for the command patterns. You can just use what's there. Still no questions? Perfect. So this was too much for you. Okay.
Can you elaborate a bit on how you do distribute debugging in Pragmatic Microservices? So how do you actually need to identify deadlocks or pattern throughout different services?
Okay. The question is how to identify problems. So first, you can expose the debug port is not a problem at all. So actually, I was asking the recent project in Whitefly if you exposed 8787. This was actually one of the last commits on Docklands. You can expose the port, you can debug as always. So there's no difference to before. But what's different is, I mean, this had nothing to do with that. So how I debug the stuff. So if the application has a problem, I would run it in controlled environment first, so for debugging. And then I will launch it without Docker. And then two great tools, JVisual VM is the starting point, or Java Mission Control, and I will see everything. So for the logs, synchronized problems, is Java Mission Control perfect. Just for performance problems is JVisual VM. So this is the answer. What's different in microservice projects, so this year, customers ask me about microservices. Okay, if you take microservices seriously, we have to perform stress tests. And what we do then, we have no time for this. I usually create a system test, which is basically the JAX-RS client here in another Maven project, and I record a stress test. In this stress test is performed by JMH. JMH is Java Micro Harness. This is a part of OpenJDK, and you can just run it, and I try to overload the server and monitor the server and see what happens. So, and because now we are in the microservice hype, we get usually budget for stress tests. A few years ago, no one was interested in stress testing the applications. So this is so basically, it's no difference to before, but right now, because everyone thinks everything is distributed, we get more time for testing. Another question? Oh, always use it in production, because Docker Compose would chain the Docker images together. You can just say Docker Compose up, and everything is started. So what I wanted to show you here is the worst possible case. No tools, what we can build in 40 minutes, and how it actually feels. What is the development speed? Usually I have scripts and whatever, and usually I use Jenkins. So the Jenkins automates everything. So there's not like I'm fiddling with the command line. Any other questions? On that note,
Why don't you run Maven within the Docker environment?
Because in my eyes, the Docker build, the chaining or the pipeline is responsibility of Jenkins. And for me, this Maven clean install has to be crazy fast. So I would like to have as fast as possible all the unit tests executed, and then the Jenkins pipeline runs. And on Jenkins, there's one liner. So I don't need a Docker plugin in Maven to have one line Docker thing. And if the Docker command line is the REST interface. So you could even call Docker directly with curl or whatever. So you don't even have to install Docker command line interface on Jenkins. Other questions? So then I show you. Yeah.
How have you been approaching
Corporate proxy. So usually this happens behind the proxy. So what in my project is like, they have a huge monolith without any reason. And then we simplify the monolith and build smaller monolith, but it runs like it runs behind the corporate proxy. It's not like we are communicating back and forth. What usually happens in addition, we get Varnish or Squid proxy as reverse proxy as cache. This is what we get now more frequently than before, so we can just do it with Docker. It's incredibly simple. And we have no time, but usually I show HA load balancer, so it uses the clustering. So we don't use the native application server clustering capabilities anymore. We rely more on HA proxy. Why? Because we can use freely different versions of application servers, and different JVM versions even. So what I wanted to show you, what Docker comes with is a registry. And this is built in. Registry version 2. This 2 is important. So now it started. So it's, the first time it will download from the internet is already downloaded, so it's already there. And what I could do, I can say docker tag Øredev, let's say macro is the latest. And then I will just copy that. I would take it into localhost 5000. And then here, the macro. And what I can do right now is docker push, localhost 5000, Øredev macro. Cool. And this takes forever, the first time. So this was the first start of the Docker registry, and all the Docker layers, so there's the whole operating system, JVM, Whitefly, or Payara, I don't even know, and my war is uploaded to the registry. What the registry is like NPM manager, private NPM manager, or Nexus, or JFrog Artifactory. And so watch this. And now I would like to rebuild the system. So now it's full build. And I think the macro was changed. Yeah, it was not cached. And I will have to tag it again, and then push it again. You see this? It recognized nothing changed but my war. So what it actually means, the first upload is slow, but because we have application servers, the images are stable, they don't change a lot. So once or 3 months, you will have to wait for this, and everything is blazing fast. And the cool story is, I won some projects only because of the speed. There was no other, no other technology without deployment which is comparable with the deployment speed with Java EE. This is per accident, but still interesting if you have Docker. Why is the registry? This is the interface between the developers and operations. So what usually happens in serious projects, we have like the base Java image and the whitefly image and whatever image are built by the DevOps, by the operations, by the admins, push to the registry. We just pull the image from the registry, run it, and in the Jenkins pipeline, each commit results in a new image, which is pushed to another registry. This is like the prod registry. And from this registry, the images are checked out and built, Docker pull. So no one builds the images in production. And the only thing which can go wrong is like, occupied port. Questions? So then the counter thing is, of course, Docker not push rather than pull. And it says everything is up to date, so nothing to do. So and this would happen. So in production, you would say Docker pull the changes, and run the image. Okay, still 5 minutes to go, 4 minutes. Any other questions? No questions? Yeah. Right now, in a smaller project, we use exactly this registry. In larger projects, we use, for instance, if you have Red Hat Enterprise Linux, it comes with, it's called Satellite, and it comes with built-in registry. Or some companies have Nexus. The version 3 of Nexus is able to manage Docker images as well. And this JFrog Artifactory as well. So I think this is nice. This actually is usable, but corporates or larger applications already have Nexus or whatever, or if they pay for operating system, it usually comes with blessed Docker image registry. And this was also a big selling point on admins and operations, because they thought, like, we have, to pull the images from the internet. What I did right now, this is not the case. You would get a Red Hat Enterprise 7 server image pulled from Satellite or the SUSE image or whatever, or Ubuntu. Okay? Any questions? Okay, the question is, what about persistence? So right now, it does not matter because they were transient, but if I had a database, what happens then? So in one of my projects, we use Elasticsearch. It has to be persistent. So you can add volumes. So we do it, it's a smaller project. We just, at startup, you can assign a host volume. But Docker is smarter than this. You can have like, how it's called, storage plugins or whatever. And you, drivers, yeah, you can point to whatever you like. So you can map this to Amazon or whatever. Usually we use host volumes right now, so there is no difference. So it's not like, my projects are, I would say, down to earth. So what we try to simplify the process with that, and by accident we call it microservices, and it fits well. But in my world, if we build a microservice, there's always an easy explanation why we build it. So either there were some problems with performance, we have to isolate this, or we have independent teams or different versioning schemes, release cycles. So there's not like we're building 20 microservices just for fun. Okay? Any other questions? Pardon? How much? Web methods. My vision of microservices, there are coarse-grained. So I would say one small team, 2, 3 people, build something, and this is the microservice. If they are productive, it could be large. So there's not like, we are only allowed to have, 5 endpoints. It has to, usually what it is like something consistent from business point of view. It makes sense in isolation. This is a microservice. So we consider it from business point of view, we're not counting the endpoints. I mentioned 100 as a joke. In my projects are 5 to 10. And if you think about this, if you have a team of 3 developers, you have 10, 30 developers, this would be a huge project. If you put politics aside, with 30 developers, you can build an operating system. But for instance, if you go to my blog and search for Commerzbank, there was a large project before, and there were 4 developers who would create 8 microservices in the shortest amount of time, just because they were motivated with exactly the same approach, for instance. And they were so productive that we invited to Commerzbank Tower to explain what we actually did, because we didn't use any corporate framework. Okay? Just plain old Java technology. Okay, so then thank you. I really have to go. If you need a nice sticker, here is it. And I have to go to Copenhagen, otherwise I can spend the whole night with you here, okay? So then thank you, and see you probably next year.